Hello everyone. In this video, we will continue with the actuarial notation, doing some calculation regarding the survival probability and mortality probability. Recall the relationship. We have S0x plus t equals S0 of x times Sx of t. In terms of the actuarial notation, S0x plus t is x plus t p0, and S0 of x xp0, and Sx of t is tpx. So we have this relationship, x plus tp0 equals xp0 times tpx. This is for the survival probability of a newborn, and we can extend this to any age x. For n greater than or equals t, the probability that a person age x survive at least t years, which is tpx, can be factored as npx times t minus n p x plus n. That is the probability that a person at age x can survive t more years at least. This is tpx, which is equivalent to a person survive up to age x plus n. The probability is npx. Starting at age x, survive for n years. And then at age x plus n, survive for the remaining years t minus n years. So we have t minus n, p x plus n. And we have the general expression for that. T plus upx, a person at age x can survive at least t plus u years, factors into a product of tpx times upx plus t. Starting at age x, survive to age x plus t, and then survive for the remaining or survive for at least u more years, reaching age x plus t plus u. So we get this relationship. Let's take a look at an illustration. 15px can be factored as 10px times 5px plus 10. A person at age x survive at least 15 more years equals to the person at age x survive to 10 years, reaching the age x plus 10, and then survive for 5 more years. This can also be factored as 5px times 10px plus 5. Any combination will do, okay, as long as we get two numbers, add up equals 15. So that is 15px can also be factored as 7px times 8px plus 7. This is for survival probability. If t is an integer, tpx equals to a product of survival probability for a 1 year period. Okay, so tpx equals px, a person age x survive for 1 year, reaching age x plus 1, and then survive for another year. So this is px plus 1, reaching age x plus 2. The probability of surviving 1 more year is px plus 2. So tpx equals px times px plus 1 times px plus 2 up to px plus t minus 1. Okay, however, this relationship does not apply to mortality probability. Okay, TQX is not the same as this expression. Instead, we express TQX as 1 minus TPX, and then we get the expression for TPX. And this is how we obtain TQX. And then for computing deferred mortality probability, U bar T QX, there are three forms. This corresponds to the probability that Tx is between U and U plus T. A person at age X can survive U more years, but will die within the next T years. In terms of the distribution function, this is fx u plus t minus fx of u. In terms of the survival functions, we have sx of u minus sx of u plus t. Convert this into actuarial notation. So we have the first relationship, u bar t qx equals u plus t qx minus uqx. And in terms of the survival probabilities, u bar t qx equals upx minus u plus t px. And then the last form, in computing deferred mortality probability, we can regard this as a person at age X survive to age X plus U, but will die before reaching age X plus U plus T. So this can be expressed as UPX, a person at age X survive at least U years, and then times TQX plus U. The person already survived up to age X plus U, but will die within the next T years. So we have the probability TQX plus U. So these are the three forms in computing deferred mortality probability. Let's take a look at a series of examples. Okay, in this example, given that F0 equals T over 100, and we would like to calculate the following probabilities: 5p60, 10q50, and 3 bar 5 q70. All right, so part A, 5p60, a person at age 60 can survive to 5 years at least. So we have S60 of 5 corresponds to the symbol 5p60. So this is S065 over S060. And we are given F0 of t. Translate this in terms of F0. And then do the substitution, and we get the probabilities. 5p60 is 0.875. A person at age 60 can survive to at least age 65. And then part B, 10q50. A person at age 50 dies within 10 years before reaching age 60. We have the notation F50 of 10. This is expressed as this F060 minus F050 over S050. Upon calculation, we get the result 0.2. All right, and then part C, 3 bar 5 Q70. A person at age 70 survived to age 73, survived for 3 more years at least, but died within the following 5 years, starting from age 73. So that is a person survived to 73, but died before reaching the age 78. So this can be expressed as 8q70 minus 3q70. And then expressed in terms of F70, which is F70 of 8 minus F70 of 3. In terms of F0, do the substitution, and then we get the result 0.0714. All right, the next example. Given the survival function of a newborn, S0 of t, which is 1 minus t squared over 100, and we would like to calculate the probability that a person at age 4 survives beyond age 5. And then part B, the probability that a person at age 5 dies between ages 8 and 9. All right, part A, the corresponding actuarial notation is P4. Expressed in terms of the survival function, this is S4 of 1. Transform into an expression involving S0. This is S05 over S0 of 4. Do the substitution t equals 5 and t equals 4 respectively. And then we get the probability 0.8929. And then part B, the actuarial notation, 3 bar Q5. A person at age 5 can survive for 3 years at least, reaching age 8, but died before age 9. So dies within the following year after reaching age 8. So we have 3 bar Q5. In terms of the survival function, S5 of 3 minus S5 of 4. And then written in terms of S0, we get S08 minus S09 over S0 of 5. Upon substitution, and then we get the corresponding probability, 0.2267. All right, the next example, you are now given a mortality table. The X is the age, and QX, the mortality probability. So we would like to calculate the probability that a person aged 78 will die between ages 80 and 83. So at age 78, the probability of dying in the next year is Q78, which is 0.01. 1% chance that a person at age 78 dies before reaching age 79. And then similar interpretation at age 80, the probability that the person died before reaching age 81 is Q80, which is 0.04. All right, we want to get this probability. A person aged 78 died between ages 80 and 83. So we have the notation 2 bar 3 Q78. This is a deferred mortality probability. We have 3 ways to do the calculation. This can be expressed as 5Q78 minus 2Q78, or 2P78 minus 5P78, or the last one, we will use the last one, 2P78 times 3Q80. The person survived for 2 years. This is 2P78, reaching age 80, and then dies within the next 3 years. The probability is 3Q80. We are given the mortality probability for each year for a 1-year period. So TP78 equals P78 times P79. So we can do the calculation from the figures in the mortality table here. And then the second notation, 3Q80. Remember that 3Q80 does not equal to Q80 times Q81 times Q82. Instead, 3Q80, we express this as 1 minus 3P80. And then we can use this relationship, the product of the P's, to get 3P80. 3P80 is P80 times P81 times P82. All right, so we get the expression in terms of the P's, but in the mortality table, we are given QX. So make use of the relationship that Px equals 1 minus Qx. And then we get the following expression. P78 equals 1 minus Q78, and P79 equals 1 minus Q79, etc. We get all the Q's. Q78, 0.01, Q79, 0.02. Upon calculation, we get the result. We get the answer 0.1984. This is the probability that a person at age 78 will die between ages 80 and 83. That's it for today's video. In the next video, we will talk about the force of mortality. Thank you for watching and see you in the next video.